Hi, in this video let's see the proof of Bayes' theorem and some problems based on that. Now check the statement. Let A1, A2, etc. An be a set of exhaustive and mutually exclusive event of the sample space S with P of Ai not equal to 0 for each I, and if A is any other event associated with Ai, and here you can see the formula, P of Ai given A is equal to P of Ai into P of A given Ai divided by summation I is equal to 1 to n P of Ai into P of A given Ai. This is what we are going to prove. Okay. Now let's see the proof. So now we have S is a big sample space that contains A1 etc. up to An. So S is a bigger sample space and all these small things are there inside S. So I can write this S as A1 union A2 etc. union An because A is a subset of S. So since A is any small set, I can write it as A as S intersection A because this is a bigger set, this is a smaller set. If I take intersection, I will get A itself. Now I am going to substitute this S. Okay. Already I have written S as A1 union etc. union An. So I am going to replace this. So once I replace this, what I will get? A is equal to this A1 to An union, okay, intersection E. The same thing is here in the proof, you can see. So after this, I am using the distributive law. So I can distribute A1 intersection A, then next A2 intersection A, etc. An intersection A. That is what you are seeing in step 3. Okay. So the step A is equal to A1 intersection A. So now in the question they have given two things, right? One is mutually exhaustive and the second one is mutually exclusive. So what do you mean by mutually exclusive event? If happening of one or the other event prevents the happening of other. So then I will call it as mutually exclusive and we have some basic properties for that. And also remember the conditional probability formula. That P of A intersection B is equal to P of A into P of B given A. So this formula also we will be using it. So fine. So we are using the mutual exclusive property. Now after that what we are going to do is we are going to find the probability of A. I know what is A. What is probability of A? So this is nothing but probability of first term A1 intersection A plus second term A2 intersection A, because this is the addition rule of probability, right? These things are there. Then the third one is and so on, plus P of An intersection A. Okay, this is the intersection. So now for this, I am going to use the property of conditional probability. So in the place of A, I have A1. In the place of B, I have A. Okay. So if I replace this, what I will get? P of A1 into P of A given A1 plus P of A2 into P of A given A2. Let it be a rough work. Okay. So I have written till the last term. And if you see here, I am writing it in general. Summation I is equal to 1 to n. So here A1 is there, then A2 is there, etc. An is there, right? So I am writing P of Ai in general. I varies from 1 to n into P of A given Ai. So I have reduced P of A to this format. Summation I is equal to 1 to n P of Ai into P of A given Ai. So what we have to prove is, if you see the question, we have to prove this. P of Ai given A is what we want. So I am going to find therefore P of Ai given A. I am going to use the conditional probability formula. Again P of Ai intersection A divided by P of A. So now in the denominator P of A, I am going to substitute what I got here. So P of again Ai intersection A, again I can use this formula. What we have written in rough is here. So these are all my rough work. So I am going to use this formula. A intersection B is equal to. So P of A into P of A given B. Sorry, B given A. So in the place of A, I have Ai now. So P of Ai into P of A given Ai divided by P of A. So P of A, whatever summation I have written, I'll just substitute. Summation I is equal to 1 to n P of AI into P of A given AI. This is what we have to prove. So what we did, we wrote what is S, and then we wrote what is A, and then we found what is P of A. After finding P of A, directly I'm going to this. P of AI given A is what we have to find, and we have substituted by using the conditional probability formula, and in the denominator we have written this, whatever we have obtained, that summation I, we have substituted, and hence we proved Bayes' theorem. Now let's see some problems based on it. Check this question. 3 machines A, B, C produce respectively 50%, 30% and 20% of the items in a factory. So I don't know. So we have 3 machines, machine A, machine B and machine C. And machine A is producing 50%, machine B is producing 30% of something, and machine C is producing some 20% of something. This is for a rough work. So out of this 50% of, say, pen or whatever it is, pencil, whatever it is, in this they are finding the percentage of defective outputs of these machines are 3, 4 and 5 respectively. So out of this they are saying from machine A it is 3% defective, from machine B again it's 4% is defective, from machine C it is 5%. So an item selected at random is found to be defective. What is the probability that it is from the machine A? So in general I'm choosing one product. Okay, I don't know whether the product is from A, B or C. After selecting the product, they are asking that what is the probability that being it is found to be defective. I'm picking one item and it is found to be defective. So now they are asking what is the probability that it is from the machine A. So let D be the probability of choosing a defective thing. So they are asking A given D, because this is already done, because I have already chosen a defective one. So this is already done, and what is the probability that it's from the machine A? So we are going to find P of A given D. Okay. Now before finding P of A given D, now we will find the individual cases. Let A be the event that the item is from the machine A. So machine A is producing 50% of the item. So P of A is nothing but 50%. So I will write 50 by 100. So 0.5. So this is given 50%, right, for A. So similarly for B, they have given 30%, right? So P of B is equal to 30 by 100. So probability of selecting an item from the machine B. So this is nothing but 0.3. Similarly, P of C is, they have given 20%. So it is 20 by 100, that is equal to 0.2. So we have got all these three values. So what is the probability that the item selected is from the machine A is 0.5, from B is 0.3 and from C is 0.2. So now we are going to find the probability of defective item, right, if it is from A. So because for this main formula, remember we are going to find P of A given D, right? So better, why I need all these things means, I will write the formula P of A given D is what I have to find is nothing but P of D given A into P of A divided by P of summation we wrote, right? Same way, defective from A into P of A plus defective from B into P of B plus defective from C into P of C. This is the formula. For this formula only, I want all these things. So I got P of A, I got P of B, I got P of C. Now I have to find P of D given A. So in your question, what they have given, 3% of the machines, right, the percentage of defective output. Let me go back to the question. The percentage of defective output of these three machines are, they have given 3, 4 and 5. So defective from A is 3%. They have given percentage. So I have written this as 3%. That is nothing but 3 by 100, that's equal to 0.03. So, and then the next one is defective from B. They have given 4%, and then it is 4 by 100, that's equal to 0.04. And the next one is defective from C, that is nothing but 5%. So that is nothing but 5 by 100, that's equal to 0.05. So I'm selecting something from A and found it to be defective. So this is P of D given A, this is D given B, and D given C. Now we got all the values, just we have to substitute this. What is P of D given A? 0.03 into P of A is 0.5. We have written already, divided by, the denominator is quite lengthy, oh my god, 0.3 into 0.5, again plus 0.3 into 0.04 plus 0.2 into 0.05. Just we have substituted all the values. So see here, P of D given C, D given C is D given B is 0.04, I have written here. D given C is 0.05, I have written here. If you just simplify these values, you will get 0.4054. So this is the solution. So this problem is based on Bayes' theorem, and when we have multiple options and we are choosing defective from a particular option, then this formula applies here. So always check the probability should lie between 0 and 1, and practice more problems for Bayes' theorem. Thank you.